this is the correct heliocentric explanation of retrograde motion of planets. By the way, this is a diagram that you need to be able to reproduce step by step on your own. So here we have the Sun and two planets, a inner planet and an outer planet here. So for example, the inner planet could be Earth, and then the outer planet would be Mars. Each one of these dots in the orbit of the planet represents the position of the planet at a different time. And on the outer planet, this is the position of the outer planet that corresponds to the same time as the position of the inner planet. So for example, here, these two dots represent the position of the two planets at a certain time, and then these dots are the position of the two planets at a different earlier time. So by the way, the direction of motion of the planets around the Sun, if viewed from north, so out of the page is the North Pole of the Earth, then the direction of motion is counterclockwise. This is standard. And so here we would draw the position of planet 1 and then the corresponding position of planet 2. And so you can draw a bunch of different points separated by equal distance because this is equal time interval. Something we will learn soon is that the larger is the orbit of the planet, the slower is the planet around the Sun, which means that the distance between the points, between the different positions of the planet around the Sun, the separation between these points is smaller. So the distance between the points is smaller because the planet travels a smaller distance. So in a given time interval, Earth travels a longer distance than Mars. Now, when we look at a planet from Earth, what we see is the planet in front of distant stars which are fixed in the celestial sphere. So now imagine the celestial sphere as this huge sphere that surrounds the Earth. Now, from the position of the Earth, you would be looking towards planet Mars, and you would see the projection of Mars in front of the star. So Mars would appear at position 1. So 1 can be anywhere along this line of sight. This would be a two-dimensional picture. Everything would appear to be in the same plane. So position 1 would be in front of or next to this yellow star here. Later on, when Earth moves at the same time Mars moves, and you look at the direction of Mars, well, the projection of Mars would be up here. So it would appear as if Mars has moved forward relative to the distant stars. Now Mars is near this star here. And as the Earth appears to overtake Mars, so if we look at the third position, Mars is still going forward, but then the fourth position here, as the Earth overtakes Mars, the angle seems to the angle seems to go back, right? So let's say the fifth position here, the direction of Mars is actually back. Mars appears to be moving backwards. And this is simply an optical illusion. As we overtake a slower planet, we have the impression that the planet is moving backward relative to us. But truth is, Mars is still moving forward. And so later on, as the Earth gets really far away from Mars, this forward motion will resume. So you can try to reproduce this diagram and point by point do all the projection and then connect the dots and see that you get this retrograde motion.